and that person's name is Lupe. And notice the student named Lupe has a study buddy, and that's pointing at Chris. So we could pair together these study buddies by simply pointing at another student object using a student reference. So in the student class, we would have a student reference. And what would that be called? Well, maybe something like this, right? You have a study buddy, I missed a D here, but you have a study buddy reference. So notice in this case, the name of the class, we're in the student class, but the name of the data type of this study buddy reference is in fact another student. So the target and the source are both students. Does that make sense? Then look at how this follows, right? Look at how this follows, that here we have a study buddy, the type is student. If you say get study buddy, it's going to return a reference to a student that is that person's study buddy. And if you say set study buddy, you tell me the buddy and I will set the reference, all right? So we can have all of these methods that work with another student reference, just like we could with any kind of other reference that we might have used in the past, right? And you can see the usefulness of this, right? You can see this fact that, hey, if you find any student, you can find out whether that student has a study buddy, right? It's really easy to do, right? You see if that reference is null. In this case, poor Pat. Pat is all alone. Pat has no study buddy, but everybody else, you could say, hey, who's your study buddy? And you could find that. You could follow that reference and go find out, okay? So you can imagine a lot of things. And again, one of the things that we've tried to do in our projects is really open your eyes to saying, look, references can be used any way that you want to, right? You can imagine scenarios. And some of you wanted to apply this to the project and say, well, if we have this thing, why can't we do this other thing? And that, it really opens up the world to our imaginations, that references can be all over the place doing, interesting things for us, right? Can I get a check-in from everybody? How are you doing on this concept so far? Can you give me a thumbs up or ask a question or give me a thumbs sideways? Anything that we can do to help you understand this? Khaled, are you good? Mayumi, maybe I missed your thumb. Are you okay there? Idris? Okay, I think I've seen the thumbs. Okay, so everybody's good, no questions so far. Okay. So we're going to get into some mind-bending sort of things next as we move forward to understand about linked lists. So here we go. Okay. So here is the first set of concepts. I'm going to drop out of PowerPoint because I want to use the surface here to draw on. So I'm going to actually be in PowerPoint proper instead of worrying about the slide presentation view, right? So here I go. Let's hide. Okay. So here's the idea that I want to talk about. What if we had a bunch of students sitting around a table, right? And let's say that the letter on these are bad representations of a student in the lower right-hand corner. Each one has a big old head, and on their head we have the first letter of their name. We want to get a sorted list, right? We want a sorted list. So one way that we could do this, if this were going to be in an array, we could go figure out what the lowest one was, or we could do some sorting algorithm to get these in an array. But the interesting thing that we start thinking about now is, do we have to physically move these people around to get them in order, right? And the linked list theory says no, right? We don't actually have to physically move people, because when you do a sorting algorithm on an array, it physically moves things around, right? It takes time, it takes energy. You have to swap and compare and move stuff around. Do we have to do that if we use this linked list theory? And the answer is, well, let's see, right? Let's see what happens. So let's say here is student A, right? If I want to say, hey, this person is the first person in the list, right? This person has the lowest alphabetical name. All I have to do is have something pointing at that person and say, hey, the first one, the front of this particular list, this alphabetical list, points to student A. What do I then have to do with student A's hand? Who does that need to point to?
To student C.
Needs to point to student C. So student A says, oh yeah, that's the next one, right? After me comes that one, comes this C person. And then C needs to point to
H.
H. Then H needs to point to
K.
K. And then K needs to point to
Null.
nothing. So K's hand is still pointing at the ground, right? Because they're like, I'm the last one, so I don't have anybody to point to, okay? Notice the interesting thing is we have an alphabetized list, because if I simply start here and go to student A, because I already know that's the first one, and A says, yep, that one's the next one, I can go to C, then C points me to H, I can go to H, then H points me to K, and I can go to K, and then I see that K is pointing to the ground. I can get an alphabetical list, and I didn't have to make anyone get up, right? No one had to shift their position, no one had to move. I just used pointers to tell me what's the next available thing, right? What's the next thing in the sequence? Does that make sense? So that's kind of cool, right? That's kind of cool. Now, cooler yet, right? Establishing that first list is one thing, but let's talk about when somebody new joins the party, right? Somebody new comes into the picture, and that is, hey, we got student G here, right? So in this case, if we have student G, how do we insert student G into the list, right? And Gary, yes, we'll come back to your question in a minute, right? We're going to come back to Gary's question about the list in both directions. But how do we get G integrated into the party here? Somebody tell me whose hands I need to move to make that happen.
C has to point to G, and G has to point to H.
Okay,
But
so
H will still.
That's right. C points to G, and then G has to point to, if I can grab the hand right, needs to point to H. Long, long hand. Okay, long arm. Make sense? To add somebody new in the middle, all I had to do is change 2 references, right? I had to make sure the one before G points to G, and the one that G is pointing to is the one that C used to point to, right? Does that make sense? All right. So great analogies, right? Great analogies so far to understanding how linked lists are going to do. Okay, yeah, Ben, go ahead.
So this is why it's not fast access speed and random access is not, because since they're all linked, then it's like you have to.
Yes, exactly what Ben says. There's no random access because there's no contiguous memory. There's no way to jump immediately. If you want to traverse the list, you got to traverse the list starting at the beginning and following all of those references. Exactly. Ain't going to be fast, right? But is it easier and is it faster to insert someone in the middle of the thing? Absolutely, right? And Blake just talked about a cassette tape. You're just splicing a little bit of tape in the cassette where you want it, right? You're just adding a little bit of extra tape and splicing it right in the middle where you want it to be, okay? Now, any other questions about that? I want to address Gary's comment in the chat in a second about both directions, but anybody have questions about this so far? What about...
You mean on search it has always to start in the beginning?
That's right. Idris has asked, do we always have to start from the beginning? Yeah, typically, anytime you're going to do an operation, you got to start at the front and you got to walk through the list to find the thing you're looking for. So searching is not going to be fast, and we can't do a binary search here, right? Because binary search assumes, as you know, that we have direct access to things by their order, and we don't here. So yep, you're going to always start from the beginning and you're going to march through the list one by one if you're looking for something. Yes, thanks, Idris. Okay, who else? Okay, so hopefully you see that removing somebody from the list actually is very easy too, right? If we want to remove H from the list, we can again map a couple of fingers to point to different people, and it is very easy to do. All right, now to answer Gary's question, can you do it in both directions? Well, in this case, if the humans, which we do, have 2 hands, right? Couldn't we have one that started at the end and then the other hand, my left hand points to the next person and my right hand points to the previous person? I got two hands, I got two fingers. I'm going to point in the next direction one way and the previous direction the other way. Sure. Again, the whole magic of data structures is you can do anything you want, right? Anything that makes sense, you can make it happen. So absolutely possible. And that's called the doubly linked list. We're going to look more at that detail later. Okay, so we'll come back to that. All right. Now, here's the subtlety, though, that gets really interesting about memory, right? Let me undo my PowerPoint pointing, and let's talk about very carefully, thinking about computer memory now, thinking about these objects. What would happen, right? What would happen if I stopped pointing to A with my front reference? What if I point that to null? In terms of objects and memory as we understand it, what